Hello there, exercise 17b. We're going to look at probability distributions here. We're going to see how A-level, I suppose, extends our work on probability that we've seen at GCSE up to this point. So a little starter for us, and initially it's nothing to do with probability. It's just seeing if you can type these numbers into our calculators properly and use the calculators to get the interquartile range and also the median. So once you type it in and get the median and the interquartile range. So our calculators we've used quite a lot to get the averages, the if you like, the mean, and also the standard deviation and the variance. But we haven't had so many questions on these. Now these questions come from the fact that for A-level maths on the stats paper, part of the paper, you have what's called a large data set. And our large data set, all A-levels have them, in maths at least. Our large data set is all to do with two things, one of which is local authority data. So this is why I've chosen a question on, and we've got a few of this, local authority data on how people travel. Do they travel by, to work, by car, by bus, by moped, whatever. And you'll notice this question, it refers to the fact that one of the sections says how many people travel by motorcycle, scooter or moped. So that's the question. Type them into your calculator. I'm going to pause the video and we're going to see if you can get, remember it's a median and interquartile range. Okay then, hopefully you've managed to suss. When you bring up your screen of all the data where it says X bar and sigma X and stuff, if you press the down button, it says Q1 med and Q3, and so when I did this for this data I got Q1. So this is where it says Q1, this is the lower quartile. The med is obviously the median and the upper quartile is called Q3. Now you have to do Q3 and you take away Q1 and it gives you the interquartile range. So take away the quartiles, upper quartile minus lower quartile. That is something you need to be able to do. So make sure you can get the numbers in your calculator. Make sure you get where you can see where these are on the calculator, and then make sure you can do that. Basic probability question for us then, just off the top of the screen. Again, I'm going to make you pause the video for this. There are two questions here. One says draw a sample space diagram. What's it? It says 2 dice are rolled and the score is defined as the product of the numbers shown on. Obviously the product is what you get when you times them together. So you're going to times the two values you get from your dice, and you're going to work out the probability of scoring 12 or more, right? Okay. And then in the second question it says 4 coins are tossed. Write out the sample space diagram, list all the possible outcomes, or all possible outcomes, and then the probability of 3 heads. Have a go at that. So again, I'm going to quickly do these for you. Hopefully you've done them now. So again, it's 1, 2, 3, 4, 5, 6. You're doing it with 2 dice. When you times these together, you get 1, 2, 3, 4, 5, 6. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12. And nearly missed one. 3, 6, 9, 12, 15, 18. You can see really this is times tables at the moment. 4, 8, 12, 16, 20, 24, 5, 10, 15, 20, 25, 30. Now there is an element of you might have been able to do this without a sample space diagram, apart from the question told us it wanted us to draw it. And if it's going to give marks for drawing these out, then fair enough, we'll take the marks. There's a 12. There's a 12. There's a 12, there's a 12. I reckon it's 4 out of 36. Equal to 9th, unless I've missed some 12, so I think that's right. Next one says 4 coins are tossed. So you can either get a head, a head, a head, a head. Or you could get one tail. So I'm going to write head, 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 tail. But that tail could happen in different places. So it could be like this, or like this, or like there. So it's important to try to do this logically. So that's 4 heads. This is 3 heads. Now I'm going to do 2 heads. Now 2 heads is head, head, tail, tail. Or it's head, I suppose tail, head, tail is one option. Or head, I'm trying to think where else. Oh, it could be tail, tail, head. Effectively, I've left head at the front, and I've just moved that head through there. But if I put a tail at the front, then it's tail, head, head, tail, tail, head, tail, head, tail, tail, head, head. I think that's all of them. Again, I've got a tail at the front, I've just moved that T through there. So that's 2 heads. We could have 1 head. If you've got 1 head, it would be head, tail, 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 or just move that head through the pack, as it were. Tail, tail, head, tail, 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 head. I think that's all of them. And then none of them, well, that's tail, 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 tail. And you should end up with 16 different things there. How many of them have 3 heads? 3 heads. That's 4. I reckon it's 4 out of 16, which is a quarter. Let's check my answers. I've got a quarter. Oh, I got 17 out of 36. Oh, I just realised why, because it says find the probability of getting 12 or more. Well, okay, well, it's a completely different answer then. Let's get rid of that. So, it's all of those. It's all of those. Plus the 4 I've already got as well, of course. It's them, and it's them. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 out of 36. Always helps if you read the question. Okay, so that's me done. Example. Now I want to show you now what are called discrete random variables, and we sometimes get these written as a formula. Now notice a probability density, or a probability function can sometimes be described as a discrete random variable if only certain values are possible. So on the die, for instance, you're only going to get 1, 2, 3, 4, 5, 6. You'd be really surprised if you got on that dice a 7. That's impossible. We know that. Only certain numbers are possible. The way we say that is we call it discrete. Only certain numbers are possible. This is a posh name. So a discrete random variable is random because it could be any of these. A discrete random variable, the probabilities, as we've already know, have to add up to 1. They add up to 1. So just bear that in mind. And sometimes for some made up situation, you might get given a formula. So I'm being told here that there are only 3 possible outcomes when I do this thing, whatever it is, this event. I can either get a 1, I can get a 2, I can get a 3. Nothing else. 4, not allowed. 5, not allowed. In fact, I can't even get 1.2 or something like this. I can't get a number in between. The only values that are possible, 1, 2, and 3. So, and it gives me a formula for working these out. So I can work out the probability x equals 1, where it says when it's x equals x, it's x over 6. So it's when it's x equals 1, it's 1 over 6. When it's the probability of x equals 2, that's 2 out of 6. When it's the probability of x equals 3, well, that's 3 out of 6. And all it wants me to do on this question is to work these out. So I've worked them out. So let's see. Notice 1 out of 6, 2 out of 6. They've simplified, but it's still right. 3 out of 6, well, obviously that's a half, but it's still right. Now you can draw this in a diagram. The diagram is a bit of rubbish, to be honest. It's just like a little bar line chart. And notice I've done it in sixths here, really. 1/6. That's the same as 2/6. That's the same as 3/6. So you can see this is going up on a consistent scale, going up. Going across, we have the values which are possible, and then that's 1/6, that's 2/6, that's 3/6. It's a bar line graph. It's rubbish. But just in case you ever see it, that's really all I've shown you it for. Second question, let's see another one. Now again, it says the only possible values for this function, this discrete random variable, are 1, 2, or 3. Okay, fair enough. Find the exact value of the constant k. Alright, bear that in mind. Now remember what I've said before. These probabilities, the probabilities, they have to sum to 1. That is important. So let's go for this. So when I put 1 into this, the probability that x equals 1 is 1 over x. Oh, sorry, k over x. So it's k. Now, x in this case is 1. K divided by 1 is anything divided by 1. It stays the same. Probability that x equals 2 equals k. It says k over x, so it's k over 2. Okay? And the probability that x equals 3 is k over 3. And that is it. The only thing I can do with this is I know that these three probabilities have to add up to 1. So I can say that k plus k over 2 plus k over 3. Ooh, what happened there? Let's rub that out. There we go. That's better. Plus k over 3 equals 1. Now, to solve this, you take out k as a common factor. And you times k by 1 to get that. You times it by a half to get that one. And you times it by a third to get that one. And the great thing about that is it's equal to 1. I can add these up. 1 plus a half plus a third. Well, I think that is 11 sixths. So that means I've got k times 11 over 6 equals 1. And I can move that onto the other side, and it becomes k equals 1 divided by 11 sixths, which is 6 elevenths. We have found k. Hence show that it is a discrete random variable. Well, it's a discrete random variable if they add up to 1. So I think that is the case. So they all add up to 1. So you just really have to say and show that they sum to 1. So x is a discrete random variable. Okay, you could show that, I suppose, by saying the probabilities are k, which was 6 elevenths, plus k divided by 2, well that's 3 elevenths because I've got to divide it by 2, plus, and this one, 6 elevenths divided by 3 is 2 elevenths. So it might be better to show it like that, and they definitely equal 11 elevenths, which is 1. Find the value of the constant k for the discrete random variable, and hence find the probability. Same trick. So we can basically find these things, a probability that x equals 1. Notice it lets me have x goes up to 4 this time. So I have to do the probability x equals 1 is 1x. That's what the formula says. K times x. That's k times 1, which is k. I nearly got it wrong then. Probability that x equals 2 then is k times 2. Notice the x is the thing we sub in. So that's 2k. You can do it for 3. Probability x equals 3 is 3k. And the probability that x equals 4 is 4k. Okay, so they sum to 1. So therefore, k plus 2k plus 3k plus 4k, the 4 possible probabilities must add up to 1. How many k's have we got? Well, 1, 3, 6, 10. 10k equals 1, k equals a 10. I now know then the probability of k equals I know the value of k. And because I know that, I can now work out the probability. What's it want? It wants x is less than 3, or equal to 3 actually. So that's 3 ways of doing that. You can get 1, you can get 2, or you can get 3. When it's 1, it was just k, so that's 10th. When it was 2, it was 2k, so that's 2 tenths. When it was 3, it was 3k, that's 3 tenths. Add them up, you get 6 tenths, or 3/5, I suppose you could simplify. 0.6, there you go, I wrote it as a decimal. Another question. Another formula. Again, this time, look at the values. It lets me only use it for 1, 2, and 3. Find the value of k, we use the same trick. Probability x equals 1. It says kx plus 2 over 5. So when it's 1, it's k plus 2 over 5. When it's 2, it's 2k plus 2 over 5. And when it's 3, it's 3k plus 2 over 5. Now they have to sum to 1. So k plus 2 over 5 plus 2k plus 2 over 5 plus 3k plus 2 over 5 equals 1. So I reckon that is 6k plus 6, and move the 5 over, times by the 1, I get 5. 6k equals minus 1. Oh, k is a negative number, it's minus 1/6. I haven't got time to finish this. I'll finish this in class. We need to find it, the probability there. Other than that, I think that... Oh, there's another question as well. So we've got a couple of questions to do in class.